So you already know that functions are one of the most fundamental building blocks of any JavaScript program. And so let's now turn our attention back to functions, because there's actually a lot that we don't know yet about functions. So in this section, we're gonna study some quite advanced topics, such as higher order functions, the bind method, and also closures. And once again, it's crucial that you understand these topics before moving on to future sections. So make sure to follow this one all the way to the end. Let's start this section about functions with one of the easiest parts, which is default parameters. And a new section means new starter files. So as always, get yours from the GitHub repository and then open them up in your VS Code. So as always, we already start with strict mode here. But now let's talk about default parameters. So sometimes it's useful to have functions where some parameters are set by default. This way, we do not have to pass them in manually in case we don't want to change the default. Now in this section, we're going to continue with the airline theme that we started by the end of the last section. And so let's now create a very basic booking function. And we're going to do that starting with the knowledge that we already had previously. So without the default parameters first. So just a normal function. And into this function, we need to pass in the flight number, the number of passengers, and the price. And then let's simply use this data to create an object and push that into some bookings array. So booking. And now here we can use the enhanced object literal syntax that we learned about in the previous section. So we can now create an object with a flight num property without having to do this. Remember? So we simply define the variable here, and that will then create a property with this name and also the value that's in the variable. And then let's just log it to console. And then let's just create an array out here which will contain these bookings. So we start empty here, and then we simply push them each time there is a booking. So basically for the airline to keep the bookings in some kind of system. And this is all very fictional. It's just to show you the default parameters in this case. And speaking of that, based on what we learned in the last section about short-circuiting, how would we implement default parameters? Well, let's start by calling this function without specifying some parameters and see what we get then. So create booking, and now with just the flight number, let's say LH123. And now we need a new terminal as always. So again, I hit tab here to autocomplete the operation. And indeed, here is our browser with our page already running. Now here's some kind of problem. Oh, and that's because we called this booking here the same as the array. And so here it is then trying to push this object into itself, basically. So we need to create bookings here, giving it a new name. And so indeed, now we get here the result of this object. And now it works, and here we see the result of this booking object. And so what we wanted to see here was that the num passengers and the price are set to undefined because we didn't specify them. And so now we can use short-circuiting to our advantage because we know that these are falsy values. Okay? And what I'm doing here is basically the old way of setting default parameters, just to remember how it would work before ES6. So let's say I wanted to set the number of passengers to 1 by default. So basically, we would reassign this parameter like this. So num passengers is num passengers or 1, which is the default value. And this works because of the reasons that we learned in the last section, which is that whenever this is a falsy value, which undefined is, then the result of the OR operator here will be this second operand. So this value here, in this case, 1. And now we can do the same thing with the price. Let's say 199 is the default price. And so if we reload this now, then indeed we get our default values here. Okay, so coming from this part of the code. However, this is a lot of ugly boilerplate code. And again, this is the ES5 way of doing it. So I will take this out. Let me actually write ES5 here, because now in ES6 there is a better way. So all we have to do is to write this equals 1. And so now this here will be the default value. And the same for the price. Let's say it to 199. And now if we reload, then we get the same result here. And this here, of course, looks a lot nicer and is a lot more intuitive to read. Now, of course, we can override these defaults. Otherwise, this wouldn't make much sense. So let's try H123. And now for 2 passengers and let's say 800. And now, of course, these values are the ones that we specified here instead of the default values. Now, one thing that's really cool about the default values is that they can contain any expression. For example, we could do times 1.2, for example, then we would get this here. Okay, but what's even more useful is that we can actually use the values of the other parameters that were set before it. So here we can now say that the price should be calculated based on a number of passengers. All right. So if we now do this, create booking again, just some random flight number here. Let's say again 2, but then with 5, we will get another value. So indeed, you see 398. So the number continues down here, and then 995. And so the price is now dynamically calculated by default based on this value we specified and the number of passengers. And again, this only works for parameters that are defined in the list before this one. So this would not work because JavaScript basically specifies these parameters in orders, and as it reaches, so right now, as it reaches the price, it doesn't know about the number of passengers yet. And so that wouldn't work. Now, another thing that's important to note here is that we cannot skip arguments here when we call the function. So for example, let's say we wanted to leave the number of passengers as the default value, but then specify the price. So we cannot do this. So skipping the number of passengers now, and then only specifying a new price. So if we do this, then of course, the number of passengers becomes 1,000. Because the second argument here will always be mapped to the second parameter. So if we wanted to leave this one here at a default, there is a nice trick. So the number of passengers we can simply set to undefined. All right, and this works again because setting the parameter to undefined is the same thing as not even setting it. Remember, so when we don't set a parameter, so when we don't pass an argument into that parameter, then it will take the value of undefined. And so specifying undefined here is exactly the same. And so this is how we basically skip a default parameter that we want to leave at its default. And so now as I reload it here, you see that the number of passenger is still 1, and indeed the price is now 1,000. Okay, so yet another very nice addition to the language in ES6 here, and pretty straightforward to understand too. So see you in the next video. In this lecture, I want to quickly talk about how exactly it works to pass arguments into functions. And this goes back to the video that we had about primitives versus objects, which, remember, we also call primitive types and reference types. So this is kind of a review of that lecture, but applied to functions, because it's super important that we really understand how primitives and objects work in the context of functions. And so let's draw up a quick and simple example here. So let's set a flight number here, 234, and an object, which is basically a passenger, which in this case is me. So name, Jonas Schmettmann, and then some random passport number. So let's say just this. And by the way, I could have all of this code here as boilerplate already, so in the starter files, but I strongly believe that it's better to write the code here in the video, because then you are forced to write the code yourself, and second, it makes the examples a lot easier to understand. Anyway, I now want to create a check-in function. So basically when the passenger has already bought the flight and is then ready to check in to take the flight, and then let's say there we need a flight number and then also a passenger object, which contains data about the passenger itself. So basically we would call this function like this. So with the flight that we already have up here and the Jonas object in this case. All right. So this is our flight LH234 and this is our passenger. But now let's say that the number of the flight was changed. And so that can happen in the check-in function. And so let's now change that flight num parameter here. And this is usually not a good practice to do, so you should not change the parameters of a function, but this is just to make a point. So let's say for some reason the number now changed to LH999. And I will also change the name of the passenger. And that's because in aviation, usually they always add a Mr. or a Mrs. In front of the name, okay? So let's do that, Mr. and then just the name of the passenger. So these are some changes that the check-in function does. And then before we check in, it will just check if the passport number is correct. So let's say if passenger.passport is equal to this one, and let's suppose that this function gets this data from some database which contains the booked flights, right? Then in this case, if the passport is correct, then let's alert check in, and else alert wrong passport. Okay, and this part here will make a little bit more sense by the end of the lecture. Okay, and now what I want to do is to log both the flight and the Jonas object to the console after calling this check-in function. So flight and Jonas. Okay, and now as I save this, what do you think is going to happen to these two variables here? Can you try to anticipate it based on the code that we have here? So anyway, let's see now. And here we get checked in, which for now isn't really important. But then what we get is the flight number, which is still LH234. So exactly as we defined it here, even though it seems like it was redefined here. So it really wasn't. And then we also get the Jonas object, But now the name is indeed changed to Mr. Jonas Schmettmann. And so that's this change here that happened inside of the function, right? So maybe you actually saw this result coming because we actually have seen this happening sometimes before. But let's anyway analyze it. So this flight here is a primitive type, right? It's just a string. And as we passed that value into the function down here, then the flight number here is basically a copy of that original value, right? So flight number contains a copy and not simply the original value of the flight variable. So this would be exactly the same as writing flight number equals flight. And this would then also simply copy this value to flight num, right? And so again, flight num here is a completely different variable. And therefore, as we changed it here, it did not get reflected in the outside flight variable. Okay, and so it's still LH234. So exactly for the same reason as we saw before in the primitives versus reference types lecture. But now, what about the Jonas object that we passed into the check-in function? And in that function, it is called passenger, right? And then we changed that passenger object here. And as we saw then, the Jonas object was also affected by that change. So why did that happen? And you might already know the answer. So when we pass a reference type to a function, what is copied is really just the reference to the object in the memory heap. So that would be exactly like doing this. So passenger equals Jonas. We can actually do this. And here the same, just to get as a reference, same as doing, okay? And so as you already know, when we try to copy an object like this, we are really only copying the reference to that object in the memory heap, but they both point to the same object in memory. And so that's exactly what is also happening here with the Jonas object as we pass it into the check-in function where it's called passenger. So here, as we are manipulating the passenger object, it is exactly the same as manipulating the Jonas object. Once again, because they both are the same object in the memory heap. All right. So in summary, passing a primitive type to a function is really just the same as creating a copy like this outside of the function. So the value is simply copied. On the other hand, when we pass an object to a function, it is really just like copying an object like this. And so whatever we change in a copy will also happen in the original. Now, of course, we need to be careful with this behavior and always keep it in mind. That's because the fact that objects behave this way when passed to functions can have unforeseeable consequences in large code bases. And that's especially true when you're working with multiple developers. So let's write another quick function here to show you what can happen so that you can be prepared for the real life, basically. So let's just create a function called new passport. It will accept any person, and basically it will simply change that person's passport number. And so let's simply create a random number here, random, and let's multiply it by some huge number, and then this will create a number between 1 and this huge thing. So it doesn't really matter here. We will also now trunc as we have used before, just so that we get a new big number, which will be the new passport. All right. And so now let's call that function actually with the Jonas object. All right. So let's say that I booked the flight with my original passport number here. And so that's the passport number that the check-in function will then compare my passport to. That's why it's hard-coded right here. But now, again, I change my passport before I check in. And so let's see what happens then. So here again, we need to pass in the flight and the passenger object. So let's see. So it still says checked in here, but that's coming from this check-in function call. Okay. So then down here, the password is changed, and then there's another check-in call. So let's see the result of that. And so now indeed it says wrong passport. All right. And so what's happening now is that we have two functions manipulating the same object. And so that is creating a problem. Right? So here the exact same thing is happening in the new passport function. I'm passing in an object, and so that object here is then called person, and as the function manipulates that person object, of course it also gets reflected in Jonas. And then as we pass that Jonas object into the check-in function, then of course that passport is no longer the same as the original one. So yeah, I think this is a nice example of seeing how the interaction of different functions with the same object can create some issues here. And of course, this is just a super simple example, but I'm sure you get the point, right? What matters is that you're aware of this issue and then you can be careful with it. Let's just take out these lines of code. Also these don't really matter. Let's just make sure. And indeed, yeah, we get the wrong passport now because of the new passport function down there. Okay. Now, just to finish, in programming, there are two terms that are used all the time when dealing with functions, which is passing by value and passing by reference. And many experienced programmers that are new to JavaScript have some confusion between these terms and how it works in JavaScript. And so I want to quickly address that here as well. So JavaScript does not have passing by reference, only passing by value, even though it looks like it's passing by reference. So there are languages like C++ where you can pass a reference to any value instead of the value itself. This works even with primitives, so you could pass a reference to the value 5, and then the original value outside of the function would be changed. And this is called pass by reference. But once again, JavaScript does not have pass by reference. So if you already know some programming but are new to JavaScript, be sure to understand this. And I know it's confusing because, as we just learned, for objects, we do in fact pass in a reference. So the memory address of the object. However, that reference itself is still a value. It's simply a value that contains a memory address. So basically, we pass a reference to the function, but we do not pass by a reference. And this is an important distinction. And once again, I'm only telling you this because there seems to be a lot of confusion going on about this topic among some JavaScript beginners, and especially when they come from other languages such as C++. Let's now talk about a fundamental property of the JavaScript language, which is the fact that it has first-class functions. This enables us to write higher-order functions. But what's that all about? Well, let's see. So JavaScript is a language that has first-class functions, which in technical terms means that functions are so-called first citizens. In practice, that means that functions are simply treated as values. And we already touched on that idea a couple of times before, but this is such an important feature of the language that it's worth spending some more time talking about this. Now, why does JavaScript work this way? Well, it's simply because functions are really just another type of objects in JavaScript. And since objects are values, functions are values too. And since functions are values, there is a bunch of interesting things that we can do with them, like storing them in variables or object properties. And that, of course, we already did a couple of times before. So the function values here are marked in red, and then you see we create a function expression in the first example and an object method in the second example. So the value in the red rectangle is the function value itself that we can store wherever we like. We can also pass functions as arguments to other functions. And we actually already did that before when adding event listeners or event handlers to DOM objects. So here we have the add event listener function that you already know, and we clearly pass the greet function into the add event listener function here as a value, right? Now, to make it even more interesting, we can also return a function from another function. That sounds kind of crazy, but it can be very useful. Finally, remember that functions are objects. And many types of objects in JavaScript have methods, right? Like array methods, for example. And actually, there are also function methods, so methods that we can call on functions. So again, that sounds a bit crazy, right? But we will see how to use this to our advantage throughout this section. This bind method here is an example of that. And again, we will learn about the bind method as we go through the section. All right. Now, the fact that JavaScript has first-class functions makes it possible for us to use and write higher-order functions. So, a higher-order function is either a function that receives another function as an argument or a function that returns a new function. So let's check out both types here. First, for functions that receive another function, we have this same example as before. So here, the add event listener function is the higher order function. And why? Well, because it receives another function as an input. In this case, the greet function. And we usually say that the function that is passed in is a callback function. That's because the callback function will be called later by the higher order function. In this case, add event listener will call the greet callback later, as soon as the click event happens. It's like the greet function saying, hey there, don't greet me yet, but call me back once you're ready. And this works not only in the context of the add event listener function, but in many other use cases as well. Okay, second, we can also have functions that return another function. So we have the higher order function here, so basically this whole code block, which clearly returns a new function, which is this one. And this style of functions is also used a lot in JavaScript, but it's also more advanced and I guess harder to understand. I will show it to you in the next lecture, but we will explore this deeper a bit later. Now, just to finish, there seems to be some confusion between first-class functions and higher-order functions. Some people think that they are the same thing, but actually they mean different things. So first-class functions is just a feature that a programming language either has or does not have. All it means is that all functions are values. That's it. There are no first-class functions in practice, okay? It's just a concept. There are, however, higher-order functions in practice, which are possible because the language supports first-class functions. So it's a subtle difference, but still worth noting if you want to be able to talk like a true JavaScript master. Great! Now in the next lecture, let's actually create our own higher-order functions. Now that we know what higher-order functions are, let's actually create our own, just to demonstrate how they work. So in this lecture, we're going to create a function that accepts other functions as an input. But to start, let's write two very generic functions that do simple string transformations. So one I'm going to call oneWord, and this will simply replace all the spaces in a word. So string dot replace, and then we're going to select all the spaces. And remember, for that, we need to use this regular expression with the G flag and then replace them with simply an empty string. And then we also convert that to lowercase. Okay? So this function here would simply work anywhere in our code with any string. And it takes in one string and returns a new one without any spaces in it. Okay, let's create another one, upper first word, which also takes in a string. And so these two functions, they will later be the functions that we pass into another function. Okay, so we first need these. So as the name says, this function here will simply transform the first word of the input string to uppercase. So let's just first split the string, so by the empty string, and then we will take the result and destructure it into the first word and then all the other words, and then return a new array that we will join. So that's first to uppercase. And here I'm not explaining exactly how this all works because we already talked about this stuff in the last video. So we spread the others then also in the array, and then we join. And so you see that everything that we learned before is actually pretty helpful. Again, as always, especially helpful is the spread operator and the destructuring assignment, like we use it here. Right? And here it's actually the rest pattern. All right. So we have these two generic functions, and now we can create our higher order function. And that function will be called a transformer. And this function will take in also a string, but as a second argument, it will take in a function. Okay? And therefore, this is a higher order function. So that's the definition that we learned about in the last video. So it takes in a function, and therefore it is a higher order function. And so now let's see how we would actually call this function. So that's how I like to do it many times. So let's say JavaScript is the best. And as a second argument, I will now pass in the upper first word function. And so basically what I want the transformer function now to do with this string is to transform the string using this function here. So this function that we created here in the beginning. All right. And once again, notice how we are only passing in the function value itself. So really just the value. We are not calling this function here. Okay. We are only passing it in, and it will be the transformer function calling this function. So let's actually do that. So we will simply log to the console transformed string, and then here goes our expression. And so this is where we will now call the function. Now inside of the transformer function, this upper word is now called fn, right? So that's the second parameter here. And so fn, and then with the passed in string. Okay. And when we see the result, this will make even more sense. Okay. Let's also log to the console the original string. And so that's just str. Okay. And I also want to show you something else. So let's log transformed by. And in the last video, I told you that functions even have methods, remember? And besides methods, functions can even have properties. And one of them is the name property. So again, we take fn, which is the function that this higher order transformer gets as an input. And then on that, we can read the name property. And so now let's see the result of this operation. And so let's take a look at our interesting output. So of course the original string looks familiar, but then the transformed string indeed was transformed just as we hoped it would. So the first word is now uppercase. And so that is of course the work of this function here. Finally, we can also see that it was transformed by upper first word. And so that's fn.name. So as the property says, it is really just the name of the function. And so this one here we can actually use on any function that we have in JavaScript. And now let's try the same here with our other function. So one word, and let's see the result. Let's give it some more space here. And so here is the second output. So the transformed string is now this one here, all in one word, and indeed it was transformed by the one word function. So this one here, right? So let's recap. We're calling the transformer function here, and into that function we are passing the callback function. And remember that we call these functions that we pass, so this one and this one, the callback functions. And that's because we do not call them ourselves, but instead we call JavaScript to basically tell them later. And in this case, calling them later happens right here. So it's the transformer function that will call these callback functions. And the callback functions in here are of course called fn. And so that's the name of the function in here that we then have to call. All right. And in fact, this is exactly the same idea that we already talked about using the add event listener function, right? So let's say we had this very simple function, high five, which doesn't really do much except of logging something to the console. Let's just put an emoji here, this waving one. And so now let's say document.body.end event listener, click, and then this function. So never mind about this part here. We're going to learn later what this means. But what matters is the add event listener. And so just like our transformer function, we pass in a callback function. Okay? And this callback function in this case is also called the event handler or the event listener, but that doesn't really matter. What matters is that conceptually, this here is the callback function, and this is the higher order function. So this one is just like our transformer function, and this one is just like the one word or upper first word. Okay, so it's just a callback function that JavaScript will call as soon as we click on the body. So you see, down there now, they appear. And so only then the callback is really called. And there are many, many other examples in the JavaScript language. And this concept of callback functions is used all the time in built-in JavaScript functions. So there are many, many more examples. For example, the for each function that we call on arrays. So let's create an array here, Jonas, Martha, and Adam. And on that array, we can call something called the for each method. And we will learn about this one in the next section, actually. And then again, we pass in a callback function into for each. So let's again use high five. And so as I reload this now, then we get here these three wavings, okay? And that's because we have three elements in this array. And so as the name of the method says, for each of them, this callback will be called. And therefore, we have three wavings here. But we will learn all about the for each method in the next section. What matters here is that once again, we use the concept of the callback function here. And so this is something really common in JavaScript. Let me just write that here. Callbacks all the time. And so let's now actually take a minute or two to understand why that is. Why are callback functions so much used in JavaScript, and why are they so helpful? Well, the first big advantage of this is that it makes it easy to split up our code into more reusable and interconnected parts. So that's exactly what we have here, right? We have all of this functionality here nicely split up into their own functions, and that itself is really helpful. But there is a second and way more important advantage, which is the fact that callback functions allow us to create abstraction. So let me explain what that means. So what we did here in our code example was to create a level of abstraction. And abstraction is something really important in programming. So basically what abstraction means is that we hide the detail of some code implementation because we don't really care about all that detail. And this allows us to think about problems at a higher, more abstract level. And so that's why it's called an abstraction. So coming back to our example here, this transformer function does not care at all how the string is transformed. It doesn't care about this level of detail, okay? All it wants to do is to transform a string, but it doesn't care how it should do it. So what I mean is that we could have taken this code here and written it directly into transformer, or even this code here, right? That would have worked just the same. But instead, we abstracted this code away into other functions. So again, we created a new level of abstraction. And by doing this, our main transformer function here is really only concerned with transforming the input string itself. But no matter how that transforming itself actually works. So it's basically delegating the string transformation to the other lower level functions, which are these two. Okay? And I hope this makes sense for you. But we will also come back to this idea of abstraction later when we talk about object-oriented programming. But it's good for you to think and talk about this stuff as soon as possible so that you can start to get an idea for this really important concept of abstraction. And now with this idea of abstraction and higher levels and lower levels of abstraction, it makes sense that this kind of function here is called a higher order function, right? And again, that's basically because this function here operates at a higher level of abstraction, leaving the low level details to this low level functions. Okay? Now, they are not really called low order or low level functions, but that's just how I like to call them in this circumstance. All right. So understanding this is absolutely crucial for your process. And I actually consider this one of the most important lectures here of the course, because callback functions are really a vital part of the JavaScript language. And that's one of the main takeaways from this video. They allow us to create this kind of logic here. And so I think it's probably a good idea that you really review this really well and maybe even write your own example of something that you see in the real world using the same concept. Okay, I think that's a really good idea that you should try out. Then here in the built-in functions like add event listener and for each, these callback functions are so important and so useful because we use them to tell these functions what exactly they should do. For example, the add event listener function on its own would have no idea of what to do whenever the click event happens here, right? And so that's why we pass in the callback function here to tell the add event listener function exactly what to do. And as you already know, this is the higher order function here with the high level of abstraction, and this here is the function with the more lower level of abstraction. All right, but enough talk. Please take a minute to really review this lecture and build an example of your own maybe. And then I see you in the next video where we will basically do the opposite of this one. So having functions return other functions. Let's now do the opposite of the last lecture and create a function that returns a new function. So I'm going to write a very simple greet function here, because this is really just to demonstrate this point here as easily as possible. So here we can pass in a greeting like hi or hello or something like that. And then all this function will do is to return a new function. So as always, we write return and then simply a new function value. And this new function that we return will also have a parameter. So it will be able to receive arguments, right? And so what this function here will do is it will simply log to the console basically the greeting and then the name of the person that we passed into this function. So let's just write this and it will make sense when we see this in action. I'm sure it looks a bit weird right now. And now let's actually use the greet function. So let's say greet with hey. And so hey is the greeting here. Now, what will be the result of this function call? Well, it's going to be this function, right? And so let's store the result of this function call, which will be, as we just said, that function. I'm going to call this one greeter hey. So this value here now is actually now a function, okay? And essentially it is this function. So what this means is that we can now call this greeter function just as if it was any other function that we defined ourselves. So let's say greeter hey, Jonas, and let's call it another time greeter hey, Stephen. And now I'm going to run it. And indeed, we get hey, Jonas and hey, Stephen. And so this worked, again, because this greeter hey is essentially this. And so now we're calling it with the argument of Jonas. And so this name here is then, of course, this name that we specified here. Now the greeting is still coming from this greet function here. And in case you're wondering why that actually works, it is because of something called a closure. Now, closures are a very complex and difficult to understand mechanism that's part of JavaScript. And so there are two separate videos at the end of this section about closures. So closures is one of the most misunderstood topics in JavaScript. So don't worry about that now. What matters here is that our first function, greet, returned a new function that we stored into this variable. And so this variable is now just a function that we can call, as we did here, again, using the parenthesis syntax. And of course, we could also do it all in one go. So we can, again, call greet. Let's say hello now. And so again, this here is now a function. Okay, so if this is a function, we can immediately call it, right? And so we call like this, and then we pass in the name, which is the argument of this function here, right? And so even though this looks a bit weird, it is going to work. And so we get hello, Jonas now. All right. And now this example might look a bit weird and unnecessary for you. Like, what's the point of having functions returning other functions? Well, this will actually become extremely useful in some situations. And especially if we're using a really important programming paradigm called functional programming. And I think I've mentioned it sometimes throughout the course. And we're actually going to look at functional programming by the end of the course. Maybe not by the time I first publish the course, but certainly some point later. Anyway, make sure to understand this here, and especially this line of code. And if you understand this, then I'm sure you understood everything what happened here. Now, just as a small challenge to finish here, try to rewrite this function here using only arrow functions. And believe me, that's going to look a little bit confusing, but I'm sure you can do it. So just take some time and try to rewrite that greet function using arrow functions. And I see you here in a minute. Okay, so let's see how it's done. So greet, just going to call it R. So this one takes, again, greeting as an argument, and it returns a new function. So this means that it only has one line of code which returns something. So all we need is this arrow, and then we don't even need the curly braces, and we don't need the return statement. So what are we going to return from here? A new function. So again, an arrow function, and so another arrow here. And then simply this. Let's give it a save and a try. So greet, air, and let's use hi this time. And yeah, we get hi Jonas. Okay, so this is an even shorter way of writing the same function, but in my opinion, it's actually a lot more confusing. And that's why I wrote it using this more traditional way here. But in the end, it's also simply one arrow function returning another arrow function. And so that's the essence of this video, which I hope was clear to you. And if so, then let's move on right to the next one. In this lecture, we're gonna go back to the this keyword and learn how we can set the this keyword manually, and also why we would want to do that. So let's say we are an airline again, and in this case, Lufthansa, which is the biggest European airline group, by the way. And so let's create a very simple object for this airline with a very simple booking method as well. So we have the airline name, we have the code, basically. We also want to keep an array of bookings, so also inside of the object, and then the book method. And remember from the previous section, I will now start using the way of writing methods using the enhanced object literal syntax. And so that's simply by defining the method like this without having to write function. So remember, before this, we used to do this, right? And if you still prefer this syntax, you can still do this one, but I do actually prefer the new syntax. And so I will just start using this one now. So the flight number and also the passenger name here. So then let's log something to the console. And again, this could have been boilerplate code here, but it's also good to practice writing this. So this should be a template string, booked a seat on. So basically we want to print like Jonas booked a seat on Lufthansa flight and then the flight number. And so here we are now going to get the airline name from the object. And so we already learned that for that we use the this keyword, right? And then flight this dot IATA code. So that's going to be the LH and then the flight number itself that we pass into the function. So the flight number. So for now, this is just a nice review of how the this keyword works, right? And of course, I will now assume that you know how all of this works, because otherwise I will have to explain the same things over and over again. And so, as I mentioned before, you should only progress once you really understand a certain topic. Anyway, let's now use the book function here. And I will use the flight number 239, and then with my own name. And let's right away book another Lufthansa flight for, let's say, Mike Smith on flight number 635. John Smith. And now if we take a look at the results, then indeed, everything works just as expected, right? And so it's important to understand that the this keyword here points to the Lufthansa object itself, because that's the object on which the book method here was called. So again, that's just what I explained before, right? But now let's say that after some years, the Lufthansa group created a new airline. So let's create gyro wings here. And then a very similar object. So with the airline, the code, and also an empty bookings array. Okay. Oh, and by the way, we actually also want our book method here to add a new object to our bookings here. So that's super important as well. So I forgot that. So let's go back here. So we will say again this, and then the bookings array. And then let's push a new object in there with the flight. And so that's essentially going to be this one. So the code plus the flight number. And then also the passenger name. And then let's quickly log that to the console here. So this.bookings is not a function, and of course it's not. We need the push method indeed. And so now you see that we have an array of our two bookings here. So that works perfectly. But now anyway, going back here to Eurowings, of course we also want to be able to take bookings for a Eurowings flight. So as being this airline, right? Now taking this exact same method here and simply copying it and pasting it here is a bad practice, right? So of course we are not going to do that. So instead we will just take the method and store it in an external function. And then we can reuse that function for all of the different airlines. So what I mean is to create a new function called book, and we will simply set it to Lufthansa.book. All right. So again, this is possible because JavaScript has first-class functions. And so we can simply take this function value here. So that's this function, and then store it into a new variable, which is then going to be also the book function. Okay. Now we could have written the function here also literally, but that's just not necessary. We have it right here. And so let's just leave it there and assign it to book right here. Okay, so let's try to use this book function to do a new booking now. But what do you think is going to happen? So 23, and then let's say Sarah Williams. And let's give it a save. And now we get cannot read property airline of undefined. So do you know why this happened? Well, it's because this function here, the book function, is now just a regular function call. And so as we learned in one of the previous sections, in a regular function call, the this keyword points to undefined, at least in strict mode. All right. So once more, this book function is no longer this method. Okay, it's just not. It is now this separate function here. It's a copy of this one, but it's not a method anymore. It's now a function. And so here it's a regular function call. And so therefore the this keyword inside of it will now point to undefined. And that's why I kept telling you earlier that the this keyword depends on how the function is actually called. Okay, so make sure to understand this dynamics here. But now, how do we actually fix this problem? So in other words, how do we tell JavaScript that we want to create a booking on the new Eurowings airline? Or even, how do we tell it that we want to book on Lufthansa here? Well, basically, we need to tell JavaScript explicitly what the this keyword here should be like. So if we want to book a Lufthansa flight, the this keyword should point to Lufthansa. But if we want to book a Eurowings flight, then the this keyword should point to Eurowings. So how do we do that? How do we tell JavaScript explicitly or manually what the this keyword should look like? Well, there are three function methods to do that, and they are call, apply, and bind. So when we first talked about the this keyword, I think I mentioned these methods back then, and so now we're going to use them, at least the call and apply methods. Okay, so let me show you how. So instead of just doing this, which doesn't work, let's actually comment that out. Does not work. So instead, we use book dot call. All right. And remember that a function is really just an object, and objects have methods, and therefore functions can have methods too. And the call method is one of them. And in the call method, the first argument is exactly what we want this keyword to point to. So let's say we want an Eurowings flight. And then, as usual, the rest of the arguments. So 23 and Sarah Williams. All right. And then let's log to the console also the Eurowings object. Let's run this, and then I will explain a bit better what just happened. But indeed, we now have the bookings array, and in there we have the object with the EW23, and so EW comes from here, so exactly from the Eurowings object, and then also, of course, the name. And again, it is inside the bookings array of the Eurowings object. So let's recap what happened here. So this time we did actually not call the book function ourselves. Instead, we called the call method, and it's then this call method which will call the book function with the this keyword set to Eurowings. So whatever we pass as the first argument of the call method. And so this allows us to manually and explicitly set the this keyword of any function that we want to call. Then all the arguments after the first one are simply the arguments of the original function. And so in the case of the book function, of course, that's the flight number and the passenger name. And of course, now we can do the same also for Lufthansa. So book.call, this time with Lufthansa, and let's book someone else on flight 239. Let's say Mary Cooper, and let's log again the Lufthansa object. And let's do it now here. And indeed, this string that we get here is completely correct. And in here, so in the Lufthansa bookings array, we now have, of course, 3 bookings. Okay? And so that, of course, happened because this time we set the this keyword inside of the function call to Lufthansa. And so now this here is again back to pointing to Lufthansa, while before, right here, it was being pointed to Eurowings. All right? So even though the code of this function is inside of the Lufthansa object, we made it so that the this keyword in here pointed to Eurowings. So to this object, this new one right here. Okay, so we have a way now of manually manipulating the this keyword using the call method. And of course, we could now keep going and create more airlines into the Lufthansa group, like the Swiss Airlines, Now, of course, these property names, they all need to have the exact same format as this original object here, because this method is trying to read just these properties. So it's always IATA code and bookings, as you see here, and airline. And so, of course, we need to use exactly these property names here as well. But just like this, we can now go ahead and use our book function on the Swiss airline. And so this time we will set the this keyword in the book call to the Swiss object. 583, and let's book another flight for Mary Cooper here. And indeed it worked again. So here is the booking again. Okay, there's just some weird thing here. And so, oh, actually here it needs to be airline as well. So I was telling you, you need to use the same property names, and I wasn't even doing it myself. So it needs to be airline just like it is here, and the same here too. And now the string is of course correct here. Okay, so let me add a comment here. Call method, because in fact there is a similar method to the call method, which is called the apply method. And the apply method does basically exactly the same thing. The only difference is that apply does not receive a list of arguments after the this keyword. So it doesn't receive this list here, but instead it's going to take an array of the arguments. Okay, and so it will then take the elements from that array and pass it into the function. So let's say flight data. So I'm just going to create quickly an array here with the flight number and the passenger name. So book on the same flight, George Cooper. And now we can use apply on the book function. So apply. And then just as here in the call method, the first argument is the this keyword. But now the second argument, it needs to be, as I just said, an array of data. So let's pass in the flight data array here. And then let's just take a look. Well, let's just take this one here actually. And so, indeed here it worked again. All right. This apply method is not that used anymore in modern JavaScript, because now we actually have a better way of doing the exact same thing. And do you know what I'm talking about? So let me show it to you. Book.call. So instead of using apply, we can still use call, again with Swiss, and then we can simply use the spread operator to take the data out of flight data and basically put them here. So this here is the same as this one. And so right now with modern JavaScript, I prefer to just always use the call method and then spread out the arguments from an array like this. So again, this here is exactly the same as this. So in summary, we now have yet another tool in our toolbox here. And this one is one that allows us to explicitly define the this keyword in any function that we want. But there is actually yet another method which allows us to do the same thing. And that's the bind method. It's more important actually than the call and apply methods, so I'm going to leave it for the next lecture. So let's now learn about the bind method. And just like the call method, bind also allows us to manually set the this keyword for any function call. Now the difference is that bind does not immediately call the function. Instead, it returns a new function where the this keyword is bound. So it's set to whatever value we pass into bind. So let's continue with our airline example from the previous lecture here. And now let's say that we need to use the book function for Eurowings all the time. So remember, we have this Eurowings object, and then we used book.call to use the book function with Eurowings set to the this keyword. So that's what we did in the last lecture. So let me just copy this code here. But now, as I said, we can use the bind method to create a new function with the this keyword also set to Eurowings. All right. So again, this will not call the book function. Instead, it will return a new function where the this keyword will always be set to Eurowings. And so let's create a new function here called book EW, which is the code of Eurowings. All right. And so now let's use this function. So book EW Stephen Williams, and we're missing the flight number here. So 23. And so as you see, this now looks like the normal book function call again. And that's because this function here already has the this keyword set in stone, basically. And so here, of course, we no longer need to specify the this keyword again. So the signature here, so the name of the parameters, is back to being simply the flight number and the passenger name. Okay, and so now again we see that Stephen booked a seat on Eurowings flight EW23. And so that worked perfectly. Let's also, of course, see the object again. So with all the bookings, and indeed, here is Stephen Williams in the flight that we just booked. Great. So this is really, really useful. And we could now, of course, go ahead and do the same for all the airlines. So creating one booking function for each of the airlines. And this then makes it a little bit easier to book a flight for each of the airlines if we have to do it multiple times. So instead of having to use a call all the time, we can just do bind once. So defining the this keyword once, like this, and from there on, we can then always use these functions. Dot bind, and this one, Swiss. All right. Now I'm not going to use them all here now because we already know how that works. All right. So this is great, but we can actually take this even further. So in the call method, we can pass multiple arguments here beside the this keyword, right? And so in the bind method, we can actually do the same. And then all of these arguments will also be basically set in stone. So they will be defined, and the function will then always be called with these same arguments. For example, we could use bind to create a function for one specific airline and a specific flight number. So let's say book EW, just like we had here, but then really specific only for flight 23. So that would be book.bind. And then of course we have to again define Eurowings, but then we can start defining the list of arguments or the list of parameters and setting the first one to 23. Okay. And so if we look at our bind function now, remember that it needs the flight number and the name. But now in our book EW23 function, it is as if this first argument was already set. And so our remaining function now only needs the name. So this function, this one now only needs the name because the number was already preset here in the bind method. So let's see. So our newly created function, book EW23, and let's now book a flight for myself. And let's book a flight for Martha, let's say Cooper. And yeah, let's check out our output here. And so these are the two. And indeed, both of them are for Eurowings flight EW23. All right. And so that's exactly what we were expecting. Again, because we preset that 23 right here. If we preset this here to 1, 2, 3, 4, 5, then of course, both of these new flights here would be booked onto that flight number. Okay. So this allows us to set in stone certain arguments. And so this function, the resulting function, then becomes even simpler. So right now, all we need to pass in is the passenger name, right? And then everything else basically happens automatically. And taking this even further, we could even define the passenger name here, for example, like this. And then this function would always book a flight for Jonas on flight 23. But that would probably take it a little bit too far. Oh, and I deleted the 23 here Of course, I didn't want that. So this is correct. And by the way, what we did here, so basically specifying parts of the argument beforehand, is actually a common pattern called partial application. So essentially, partial application means that a part of the arguments of the original function are already applied. So which means already set. And so that's exactly what the book EW23 function is, right? It's essentially the book function, but with 23 already predefined. Great. So hopefully this was a nice example for you to understand the call, apply, and bind methods. But there are also other situations in which we can use the bind method and where it is very useful. And one example of that is when we use objects together with event listeners. So let's write that here actually. With event listeners. And so now this button here will finally come into play, and maybe you've been wondering about that. But let's start by adding a new property only to the Lufthansa object. And let's set it to 300. So meaning that this company has 300 planes. And then we also add a new method only to the Lufthansa object, which is to buy a new plane. So function, and now what we want to do is this dot planes plus plus. So essentially we want to add a new plane whenever we click on this button. So eventually that's what we will want to do. And then let's also log this dot planes to the console, and probably we should also log the this keyword to the console as well. And now let's actually attach our event handler to this element. Let's inspect it here. Okay, should need to go to elements. So this is the button here, and it has the class by. So document.query selector .by add event listener for click. And then the second argument, as you already know, is the handler function. So add event listener here is the higher order function which receives a callback function. And so that should be Lufthansa.byPlane. .byPlane. All right, so essentially this function here is what we want to happen, which again takes the current number of planes and increases it by 1. So let's do that. And now as I click on this button, let's see what happens. And we get not a number here. So this dot planes is now not a number. And the reason for that is that the this keyword is this button element. Okay. And do you know why that is? Well, in one of the theory lectures, we learned that in an event handler function, the this keyword always points to the element on which that handler is attached to. So this is the handler function, right? And so it is attached to this element, so to this button. And therefore, inside of the handler function or the event listener, it doesn't really matter, but inside of this function, the this keyword will point to the button element. And so that's why this keyword here returns this button. Okay, so here you have yet another proof that the this keyword really is set dynamically. Because if we simply called Lufthansa.byPlane out here, then of course the this keyword would be Lufthansa, so this object, right? Because that's the object calling the function. But in this case, it's of course this event listener function calling this function. And so therefore, the button itself will then become the this keyword. Okay? Here we now see the result of calling this function out here. And so now we started with 300 and it was increased just as we wanted it to be. So let's take this out here and let's go back to clicking here to see the result we had before. So that's this button. Now, of course, in this handler function here, we still need the this keyword to point to the Lufthansa object itself, right? Otherwise, this logic here will not work. So what this means is that we need to manually define the this keyword right here. So right here. Now, how should we do that? Should we use the call method or the bind method? Well, we need to pass in a function here and not to call it. And so we already know that the call method calls the function. And so that's not what we need. And so therefore we use bind, because we already know that bind is going to return a new function. And so the this keyword should be Lufthansa. And so that's exactly what we define. Okay, and now as we click here, we should see the Lufthansa object being the this keyword. Indeed, that's now exactly what we got here. So that's the result of this line of code. And so again, this now points to Lufthansa, because that's what we told JavaScript to do right here. And so indeed, now the number of planes is increasing each time that we click on this button. Great. So we have our problem solved. And in fact, we will do this a couple more times throughout the course. So this one is an important one. And in general, the bind method is something you really need to understand. All right. Now, just one final example here, which is again going to be about partial application, because this is another big use case for the bind method. And in this case of partial application, many times we are not even interested in the this keyword, but we still use bind for this. All right. Now remember that partial application means that we can preset parameters. All right. So let's start by creating a general function which adds a tax to some value. So let's start with the tax rate and then the value itself. And let's write an arrow function here. And so this works by doing value plus value times the tax rate, right? So imagine that the tax rate would be 10% and the value 100. And so adding the tax to 100 would be 110. Well, let's actually do 200 to make it a bit more clear. And of course, we need to call the function here itself. Okay, so now 10% of 200 is 20, and so the result should be 220. And that didn't work. And yeah, that's because we need to define this here as a decimal number here, of course. So only then this rate here can make sense. Okay, so 220 now. So this here is the general function for adding tags. But now let's say that there is one tag that we use all the time. And so let's create a function for that. So for example, here in Portugal, the VAT, which is value added tax, is 23%. And so we can now use the bind function on this function and preset the rate always, so that it always will be this 23%. And then we have a function which only calculates the VAT for whatever value we pass into it. So add tags dot bind, and then the first argument of bind is the this keyword. Remember? But in this case, we don't care about the this keyword at all. It's not even here in the function. And so we just say null. It could be any other value because nothing will happen with it, but it's kind of a standard to just use null. And now we can set the rate here. So let's preset it to 23%, so 0.23. All right, and so this sets the rate value here in stone. So essentially this would be the same as writing, let's paste it here. So this would be add VAT equals, and the rate is preset to 0.23. So this is essentially what our add VAT function now looks like. Okay, so because we already set 0.23 in stone. So now we can start using that. So this should be 123, and it is. We can use anything we want now, like 23, and so on and so forth. So I hope this makes sense. When you want to do this yourself, just keep in mind that the order of the arguments then is important. If you wanted to preset the rate, then it has to be the first argument in this function. Otherwise, this would not really work here. Okay. Now you could argue that what we just did here could easily have been done with default parameters. But this is actually different, because this here is creating a brand new, simply more specific function based on a more general function, which is the add text function. And of course, the example here could be a lot more complex too, right? So this really is different, because using bind actually really gives us a new function. So it's as if we returned a new specific function from the add text function. And actually now I have a nice challenge for you, which is to essentially rewrite this whole example here, but using the technique of one function returning another function. So we have one lecture about that, and maybe you can go back and take a look at that. And then I want you to essentially create a function that can return a function which will do just what this one does. So that's probably really challenging. So don't beat yourself up if you cannot do it. I know it is a challenge, but you can still try to take a minute or two and really try it. If you can't do it, then just watch the solution in a minute. Okay? Just don't use bind, of course, because with that we already have the solution. So use the technique that I showed you earlier with the greet function, remember. And so here you can do something similar. So see you in a second with the solution. All right, I hope you tried that out. And here is how I would have done it. So the first function here, I'm going to call it add text rate. And I could do this with the arrow functions, but then that looks really confusing. So let's just focus on the functionality here. So this is the first function which only receives the rate. So similar to what we did here. And then what it does is to return a new function. And then this new function is the one that takes in the value. And it will then return, just as the other function, value plus value times the rate. Okay. And so now based on this one, we could create add VAT 2. And so that would be add tax rate and then call it with 0.23. And then let's just do the same to see if the results are the same. So VAT 2 and 2, give it a try. And here you go. So the results are the same. And so this add VAT 2 is the same function as this one. So just to recap, we created this function, which then returns this one. So the first one is the one that needs the rate, because the rate is also what we used to define this add VAT function here, right? And so the resulting function is then the one who takes in the value. And that's why we have value here in the inner function too. Now this is just another way of doing the same thing, and this is already pretty advanced stuff, really. So absolutely don't be upset if you didn't do this by yourself. But anyway, in the next video, we have coding challenge number 1 of this section coming up, and so I hope to see you there very soon. Welcome to the first coding challenge of this section. And this one is going to be an exciting one. Because in this one, we are building a simple poll application. So a poll has a question, an array of options from which people can choose, and an array with the number of replies for each option. And this data is stored in this object here that it already created for you. Now you can copy this object from here, or you can get it from the final code that's available for the section in the GitHub repository. Okay, so you see we have the question, the array of options, and also a new array of answers. So this code here, we will learn how it works in the next lecture, but this will create this array of 4 zeros. And that's because there are 4 options here for this question. And now here are your tasks. So first up, in that poll object, create a new method called register new answer. And this method does 2 things. So it displays a prompt window for the user to input the number of the selected option. And here I want the text to look exactly like this. Then, based on the inputted number, so the user should input either 0, 1, 2, or 3. So based on that, update the answers array. So if the user gives 3 here as the option, then increase the value at the position 3 of the array. And of course, increase that by 1. To do this, make sure that the input is actually a number, and if that number makes sense. Then I want you to call this method whenever the user clicks on this button. And so this is where the second button here comes into play. Then number 3, create a method called display results. And this one should, as the name says, display the results of the poll. Now this method takes an argument called type, and that type should be a string, as I say here. And the value of that string should either be string or array. So these are 2 different ways of displaying the results, basically. Now, if the type is set to the string of array, then simply display the results array as it is using a normal console.log. And this should actually be the default option. All right. Now, if the type is set to string, then display a string like this one here. Okay. And then once you have this method built, run it each time after the register new answer. So essentially, whenever someone clicks on this button here, it will call this this register new answer method, and then this method itself will call display results. Okay, and to do this, use as many of the tools that you learned in this section, and probably also the last sections, and really all the course itself. Now, there are a lot of moving parts in this challenge, and it might not be as straightforward as it seems here. So if you need to cut some corners and make some things a little bit easier, then that's absolutely no problem. At least just write some code on your own. That's really my main goal with this challenge. Then if you manage to do these challenges, or to do the challenge as instructed here, then I also have a bonus for you. And so that is to use this display results method that you built before to display these 2 arrays that we have here in the test data. Okay, so usually you simply use this method to display the answers array that's inside of the object. But here I want you to really display simply this array and this array. And of course, do not put this array here inside of this poll object. Okay, you should use them individually. Now, for doing this, you have to really think about what the this keyword should look like in this situation. And then you basically need to set the this keyword accordingly. Okay, so that's a nice challenge here. And one thing that is certain is that your code will look different than mine. I'm just a normal developer like anyone else, and everybody writes their own code. And so my code is different from everyone else's code, probably. And so, yeah, that's completely normal if you are starting to develop your own style. So take maybe an hour even to do all of this, and then come back to this video to check out my solution. So let's get to work here. I hope it went well for you when you tried it out on your own, and you can always share your experience in the Q&A area. Anyway, let's now get the answer here. And so for that we use prompt. So const answer prompt. And so let's see what it has to look like. So it's just a question, then it's a new line, then it's these options, another new line, and then write option number. So this part is always the same. So I'm just copying it from here. So we want to grab the question first. And so that is this dot question. Then the new line, which is this, remember. Then we want the options. And so one new line for each of these options here. So this is an array. We want to transform it to a string. And so for that we use the join method. So this one we learned about in the previous section. So I hope you remember this one. And so we take the options array here and join it. And we do join it again by the new line character. Okay. And then finally another new line, and then this part. All right. Oh, and then we of course also need to convert this result to a number. All right. So this looks good. Let's just add a comment here. So this is get the answer. And then here, second is to register. I think that's what we had here. So the first step is to get the answer, and the second is to basically update the answers. So I'm just calling that register the answer. Okay, but here let's actually start by trying it out. So let's do for now Paul.register new answer. And indeed, this is exactly the formatting we were looking for. Let's say 3, and indeed we get 3. Nice. And so now let's register the answer. And remember that we should check if this value is actually a number, and also if it makes actually sense. So in terms of the number of options. So first we check if it is indeed a number, and there are better ways of checking this, but more about that later. And we also want to know if the answer is below the length of this array, basically, right? So if the answer is 10, then that doesn't make any sense. And so it must stay below the length. So the length here is 4. And so the max reply that we accept is 3. So answer needs to stay below this.answers.length. Now here we could now do an if statement and basically saying that if this is true, then increase the answers array at the correct position. However, instead, this is actually a great use case for short-circuiting with the AND operator. So let's simply do this. So this.answers, and then we go to the position of answer, and then simply increase it like this. All right. So if this here is true, then the AND operator will keep going, right? So then this is evaluated, and if it's still true, then this here is executed. But if either one of these conditions here is false, then the AND operator will short circuit, and this part here is not executed. So this is a nice use case for short circuiting, because the code that we want to execute is just one simple line of code. Okay, so now let's then take a look at the answers. So this.answers. So this is for now the register new answer method. And now let's focus here on point number 2, which is to actually call the method whenever we click on this answer button here. So let's select that button, document.query selector, and now we need the class name. Let's check that out here again in the elements. And so it has the class of Paul. So Paul dot add event listener, click, and now the function that we want to execute. And so that is add Paul dot register new answer. All right. Now, do you think that this will work like this? And let's give it a save actually. And there is an error, and that's because we're trying to read property join of undefined right here. And so the problem here is, as you might have guessed, because we talked about this before, is that the this keyword right now points to this element. So to this Paul button here. And so again, that is because in an event handler function, such as this one here, the this keyword will always point to the element to which it is attached. And so right now, that is this button. So to fix this, we need to bind the this keyword, and in this case, we need to set it to the Paul object. And so then, in this function here, which is the result of the bind method, so in this new function, the this keyword will then point to the Paul object. So let's see that, and now indeed it works. So let's input 0 here, and indeed, we already get our array where the count of the answers in position 0 has increased. And if we try this again, it should become 2, and it does. Now, in order to actually display these results, we should create this new method called display results. All right. So it takes a string that is called type, with array being the default here. All right. So let's do this. And also keep in mind that this is the kind of string that we want if the type is string. So let's copy this one. And now here we add that new method called display results. And so it gets the type. And remember, it has the default set to array. And so here we can use the ES6 default parameters using this equal sign. So if type equals array, then simply log this dot answers to the console. Else, if the type equals a string, then we want to log something like this to the console. So once more, a template string or template literal. And actually this should be outside results are, and then do create this here. We can simply join the array together to form a string. So that's this dot results, or actually answers, dot join, and we join them with a comma and a space. Okay, and so now here, let's get rid of this console.log, and instead we will now call this method. So this dot display results, and let's actually call it twice. Once without passing any argument, and then here passing in string. And so then we will see both types of results printed to the console. And so this is number 4 here. So let's give it a save. 0, and indeed it works just the same. 3, let's try 3 again, And so indeed, it works just fine. Let me now input something else. And so then nothing changes here. So the results are not updated. And that's because of this testing logic that we have here. Great. So I hope you have been following this far. So this is similar to what we have been doing. And now let's check out the bonus here. So let's use the display results method that we just used, but to display these two arrays. Okay, let's copy them just so we don't have to scroll so much. And it says here that we should think about what the this keyword will look like. So we will do that, of course. Okay, so these are the arrays that we're going to work with. So the method is at pol.displayResults. But as I said, now we want to call this method here not with this array, so not with the answers array, but instead with this array. So what should we do here? Well, we will have to use the call method because we will need a new this keyword, right? Because display results uses this.answers. Okay, so the answers come from the this keyword. And so if we want to have a different this keyword, then we need to use call. And what should the this keyword be like? Well, we need an object which contains the answers property here, right? Otherwise, there is no way for this method to call this.answers. And so we can simply create a new object and say answers and then this array. And that's it. Let's try this. And indeed, here is the result printed. And let's even now pass in the string option. And so now indeed we get poll results are 5, 2, and 3. All right. So again, to recap, this works because this function here is looking for this.answers. But our array is, well, it's simply out here. So we need a way to make this.answers equal to this array. And so that's why we used the call method here, so that we could manually set the this keyword to a new object, which as the answers property has that new array. And now let's just try it with the other one here. And we can do the same without the string, and then it will just log the array itself. And yeah, that works just fine. Great. Now, what we did here is not really a real scenario, but it's still good for us to use these concepts in some different ways to really get used to how all of these concepts work together. Our next topic is something called immediately invoked function expressions. So let's take a look at what they are. So sometimes in JavaScript, we need a function that is only executed once and then never again. So basically a function that disappears right after it's called once. And this might not appear to make much sense right now, but we actually need this technique later, for example, with something called async await. So how could we do that? Well, we could simply create a function and then only execute it once. So run once function this will never run again, and then we can call it here. However, we can actually run this function again at some other point in the code if we wanted to, right? There's nothing stopping us from later doing run once again, right? And so this is not what we want to do. We want to actually execute a function immediately and not even having to save it somewhere. And so this is how we do that. So we simply write the function expression itself, so without assigning it to any variable. Now, if we try to run this, we will get an error for now. And so it says function statements require a function name. And that's because, of course, JavaScript here expects a function statement, because we simply started this line of code here with the function keyword. However, we can still trick JavaScript into thinking that this is just an expression. And we do that by simply wrapping all of this into parentheses. And so now we basically transformed the statement that we had before into an expression. And so now if we save this, we get no error. But also this function didn't execute yet, right? We never called it. So we know that this here is the function, and so we can then immediately call it. And so with this, we will get now this text here logged to the console, this string. And indeed, here it is. All right. So again, this here is really just the function value. So it's just a function expression. And then immediately we call it here. And so this is why this pattern here is called the immediately invoked function expression, or IFI for short. So immediately invoked function expression. And the same would, of course, also work for an arrow function. So let's just copy this. This will also never run again. So if we try to call it like this, then it would not work. And so we actually don't get an error, but also nothing happens. So we first need to wrap this into parentheses, and then as we call it, then here it is. Okay, so two ways of writing an immediately invoked function expression. But you might be wondering, why was this pattern actually invented? Well, we already know that functions create scopes, right? And what's important here is that one scope does not have access to variables from an inner scope, right? For example, right here in this global scope, we do not have access to any variables that are defined in the scope of any of these functions here, right? So for example, let's add a variable here. Let's say is private equal to 23. And then as we tried to access it out here, you already know that it's not going to work, right? And that's because the scope chain only works the other way around. So the inner scope would have access to anything defined outside here in the global scope, but the other way around, the global scope does not have access to anything that is inside of a scope. So in this case, of the scope created by this function here. Therefore, we say that all data defined inside a scope is private. We also say that this data is encapsulated. So for example, this is private here, is encapsulated inside of this function scope that's created here. And data encapsulation and data privacy are extremely important concepts in programming. So many times we actually need to protect our variables from being accidentally overwritten by some other parts of the program, or even with external scripts or libraries. And I'm going to talk in detail about these concepts in the object-oriented programming section. But for now, keep in mind that it's important to hide variables and that scopes are a good tool for doing this. And this is also the reason why the immediately invoked function expressions were invented. So basically this pattern here. So this is not really a feature of the JavaScript language. It's more of a pattern that some developers came up with and that then started to being used by many other developers. Now, do you remember what also creates a scope in ES6? And that's right, variables declared with let or const create their own scope inside a block. And we learned that in the behind the scenes section. Remember? So when we create a block like this and declare is private in there, then the outside can still not access is private. So let's comment out this one and paste it here. And once again, we cannot access this variable. While on the other hand, this one here would, of course, be accessible. And so again, that's what we learned in one of the previous sections. So that's because this one here was declared with var, and therefore it does completely ignore this block here, essentially. And this is the reason why now in modern JavaScript, immediately invoked function expressions are not that used anymore. Because if all we want is to create a new scope for data privacy, all we need to do is to just create a block like this, right? There's no need to creating a function to create a new scope. Unless, of course, we want to use var for our variables, but we already know we probably shouldn't do that, right? Now, on the other hand, if what you really need is to execute a function just once, then the IFI, so the immediately invoked function expression pattern, is still the way to go, even now with modern JavaScript. And we will actually see a great use case a bit later of doing an IFI. There is an almost mystical feature of JavaScript functions that many developers fail to fully understand. And what I'm talking about is something called closures. So when I ask my students what's the hardest JavaScript concept to understand, then many people say that it's closures. However, I believe that with the right explanation, it's actually not that hard, especially when you already understood everything that you learned before in this course, such as execution contexts, the call stack, and the scope chain. Because closures kind of bring all of these concepts together in a beautiful, almost magical way. So enough talk, let's see what closures are all about. So I'm going to start by creating a new function here called secure booking. And it is this function that will create the closure. Now, the first thing that I need to tell you about closures is that a closure is not a feature that we explicitly use. So we don't create closures manually like we create a new array or a new function. So a closure simply happens automatically in certain situations. We just need to recognize those situations. And so that's what we're going to do here in this example. So we will create one of those situations so that we can then take a look at a closure. So anyway, let's now continue writing this example. And I'm calling this one passenger count, and it will start at 0, but we will be able to manipulate it. And I'm calling this function here secure booking because this passenger count variable cannot be manipulated and accessed from the outside. So, and now what's special about this function is that it will return a new function. And what we do in this function is to update the passenger count variable. So the variable that is defined in the parent function. So that's important. And then let's just log the new passenger count to the console. So passenger count. All right. And now let's call the secure booking function and then store the result in a variable called booker. And so this is actually pretty similar to what we did previously in the lecture of functions returning other functions. So we have one function here that we call, and this function will return this new function. And so as we call secure booking, it will return exactly this function, and it will then be stored inside this booker. And so this here is going to be now a function as well, right? So let's analyze in detail what happens when this line of code here is executed using all the concepts that we already know about. So this is exactly the code that we just wrote. Now, before we start running the secure booking function down here, our code is running in the global execution context. And in there, we currently only have this secure booking function. And so we can also say that the global scope now contains secure booking. Then, when secure booking is actually executed, a new execution context is put on top of the execution stack. Now, remember, each execution context has a variable environment which contains all its local variables. In this case, it only contains the passenger count set to 0. This variable environment is also the scope of this function. And so the scope chain of this execution context looks like this. So passenger count is in the local scope, but of course this scope also gets access to all variables of the parent scopes. And in this case, just a global scope. Anyway, in the next line of the secure booking function, a new function is returned and it will be stored in the booker variable. So the global context now also contains the booker variable. And now what else happens when the secure booking function returns? Well, that's right, its execution context pops off the stack and disappears. So the secure booking function has done its job and has now finished execution. It really is gone now, and that's important to be aware of and to keep in mind. And for now, that's actually all we did. So all this is nothing new at this point, right? All we did was to analyze the call stack and the scope chain as we call the secure booking function. And this is going to be important to later on understand the closure. So as of yet, we didn't see the closure yet. All we did was use the knowledge that we already have to understand how this booker function was created, because that's going to be important for the next step. So let's now go back to our code to actually use the booker function and then finally see the closure in action. So now that we understand how the booker function was created, let's now actually call it here. So calling it a couple of times here. And as we can see, it doesn't need any arguments. There's no list of parameters, right? So let's call it here 3 times. And now let's reload the page here. And indeed, we get 1, 2, 3 passengers. And so what this means is that the booker function was in fact able to increment the passenger count to 1, then to 2, and then to 3. But now, if we think about this, then how is this even possible? How can the booker function update this passenger count variable that's defined in the secure booking function that actually has already finished executing? And so, as I just said, this function has already finished its execution. It is gone. So its execution context is no longer on the stack, as we just saw in the slide. But still, this inner function here, which is the booker function, is still able to access the passenger count variable that's inside of the booker function that should no longer exist. And maybe you can guess that what makes this possible is a closure. But before I explain exactly how the closure works, I want you to appreciate once more how strange this actually is. So again, this booker function here is simply a function that exists out here in the global environment, or in the global scope, right? And the environment in which the function was created, so this here, basically, this environment is no longer active. It is in fact gone. But still, the booker function somehow continues to have access to the variables that were present at the time that the function was created. And in particular, this passenger count variable here. And so that's exactly what the closure does. So we can say that a closure makes a function remember all the variables that existed at the function's birthplace, essentially, right? So we can imagine the secure booking as being the birthplace of this function, so of the booker function, essentially. And so this function remembers everything at its birthplace by the time it was created. And this cannot simply be explained with the scope chain alone. So we need to also understand the closure And so let me now really explain how it actually works. So this is how we left the call stack and the scope chain after the last slide. And the most important thing to notice here is that the execution context of secure booking is no longer on the call stack, because again, this function has finished execution long ago. So now it's time to finally run the booker function and see exactly what's gonna happen here. And note that booker is really this function here located in the global scope. Anyway, the first thing that's gonna happen is that a new execution context is created and put on top of the call stack. And the variable environment of this context is empty, simply because there are no variables declared in this function. Now, what about the scope chain? Well, since booker is in the global context, it's simply a child scope of the global scope, just like this. But maybe now you're starting to see the problem. So how will the booker function access the passenger count variable? It's nowhere to be found in the scope chain, right? So this is where we start to unveil the secret of the closure. And the secret is basically this. Any function always has access to the variable environment of the execution context in which the function was created. Now, in the case of booker, this function was created, it was born in the execution context of secure booking, which was popped off the stack previously. Remember? So, therefore, the booker function will get access to this variable environment which contains the passenger count variable. And this is how the function will be able to read and manipulate the passenger count variable. And so it's this connection that we call closure. So let's say all that again to make this really clear. So a function always has access to the variable environment of the execution context in which it was created, even after that execution context is gone. And this last part is really important. The closure is then basically this variable environment attached to the function, exactly as it was at the time and place that the function was created. And this probably still sounds confusing, but don't worry, I have some more familiar analogies in the next slide. For now, we are just trying to understand the mechanism behind the closure, so how it all works behind the scenes. So what matters the most here is that the booker function has access to the passenger count variable because it's basically defined in the scope in which the booker function was actually created. So in a sense, the scope chain is actually preserved through the closure, even when a scope has already been destroyed, because its execution context is gone. This means that even though the execution context has actually been destroyed, the variable environment somehow keeps living somewhere in the engine. Now we can say that the booker function closed over its parent scope, or over its parent variable environment. And this includes all function arguments, even though in this example we don't have any. And now this attached or closed over variable environment stays with the function forever. It will carry it around and be able to use it forever. To make it a bit more digestible, we can also say that thanks to the closure, a function does not lose connection to variables that existed at the function's birthplace. That's a bit more intuitive, right? But anyway, let's see what happens now with execution of the booker function. So the function attempts to increase the passenger count variable. However, this variable is not in the current scope. And so JavaScript will immediately look into the closure and see if it can find the variable there. And it does this even before looking at the scope chain. For example, if there was a global passenger count variable set to 10, it would still first use the one in the closure. So the closure basically has priority over the scope chain. And so after running this function, the passenger count becomes 1, this message is logged, and then the execution context is popped off the stack. Then execution moves to the next line, we get a new execution context, and the closure is still there, still attached to the function, and the value is still 1. And so now this function executes, increasing the passenger count to 2 and logging a message again. Okay, and that's what closures are and how they work behind the scenes. And I know that this is all quite complex, so let me give you a couple different definitions of closure now, some more formal ones and some more intuitive and maybe easier to grasp. And the most formal definition of closure is the one we already saw, which is that a closure is the closed over variable environment of the execution context in which a function was created, even after that execution context is gone. Or in other words, even after the function to which the execution context belongs has returned. Next, and a bit easier to understand, a closure gives a function access to all the variables of its parent function, so the function in which it is defined, even after that parent function has returned. So the function keeps a reference to its outer scope even after that outer scope is gone, which basically preserves the scope chain throughout time. Alright, another definition, or let's say analogy, is that a closure makes sure that a function does never lose connection to the variables that existed at the function's birthplace. It remembers the variables even after the birthplace is gone. It's like a person who doesn't lose connection to their hometown. In this analogy, the person is the function and the hometown is the function's parent scope, and the function then doesn't lose the connection to the variables stored in this parent scope. And I hope that makes sense. Finally, some people like to think of this attached variable environment as a backpack. So in this analogy, a function has a backpack which it carries around wherever it goes. And this backpack contains all the variables that were present in the environment in which the function was created. Then, whenever a variable can't be found in the function scope, JavaScript will look into the backpack and take the missing variable from there. So kind of similar to the other definitions, but maybe a little bit more visual. So these are some different ways of defining closure, but they all mean the same thing. So they all represent the same idea. Finally, we need to understand that we do not have to create closures manually. And this is also what I already touched on at the beginning of the lecture. So instead, this is something that JavaScript does completely automatically. We don't have to do anything. Also, there is no way for us to explicitly access closed over variables. That's because closures are not like a tangible thing. They're not like an object or so that we can access. So we cannot just reach into a closure and take variables from it. That's impossible, because a closure is just an internal property of a function. We can observe that a closure happens, because functions magically keep having access to variables that should no longer exist, but we cannot directly access these variables. However, what we can do is to actually take a look at this internal property, so at this backpack, so to say, in the console. So let's quickly do that before we finish this lecture. And we can do this by using console.dir, and then of the booker function itself. So similar to console.log, but this one is a bit different. And so here we now get this function itself. So we can get the arguments, the name property that we already took a look at before, and then down here we have this scopes internal property. And this internal scopes property here is basically the variable environment of the booker function. Now in here we can actually see the closure coming from secure booking. All right, And so this is where we see the passenger count, which currently stands at 3. And so this closure here basically is the variable environment of this secure booking. So that's the one that is being preserved by the closure. All right. And by the way, whenever you see these double brackets here, that means that it is an internal property which we cannot access from our code. All right. This was a long video about closures. Now, in the next lecture, we're going to take a look at 3 more examples of closures and also analyze how they work, because it's really important that you understand this concept of closures. It's a feature that's used all the time in JavaScript, and many times even without us realizing that closures are happening. So if you want to become confident as a programmer, you always need to know how exactly everything in your code works. And that, of course, includes closures. Let's now create 2 more situations in which closures are gonna appear, so that you can start identifying closures in your own code in the future. And both of these examples are gonna demonstrate that we don't need to return a function from another function in order to create a closure. All right, so let's start with our first example here. I'm gonna start by defining an empty variable called f, and then a function expression g, so these are just some generic names, because what the functions do here don't really matter. Then in here I defined this a variable, and then I'm going to reassign the f variable that we created out here, and I'm going to assign it a function value. And this function will then simply log the a variable to the console, let's say times 2. Okay, and that's it, for now at least. So let's try to call g. So that's going to be this first function. And so the result of this function is that a will be 23, and that our f variable that we have out here will become this function. And so after g, we can then call f. So let's try that. And we get 46, which is indeed 23 times 2. All right. And so what this proves is that this f value here, so this f function, really does close over any variables of the execution context in which it was defined. And that is true even when the variable itself, so f here, was technically not even defined inside of this variable environment here, right? So this f variable was defined outside here in the global scope. It was created here. But then as we assigned it a function here in this g function, so right here it then still closed over the variable environment of the g function. And that includes this a variable. And therefore it is able to access this a variable here even after the g function here at this point has, of course, already finished its execution, right? So that's just what we learned in the last lecture. So at this point of the execution, the variable environment of g is no longer there, right? But f, so this function here, closed over that variable environment, and therefore it is able to access the a variable. So basically, using the analogy of our last video, the a variable is inside the backpack of the f function. But now let's take it to the next level and create a new function here. So that's h, and it's going to be very similar. All it's going to do is to define b as some other value, let's say this, and then we will again reassign f right here. So let's call this one b now, of course. So this one here will then try to access B and multiply by 2. Okay? And so what I want to see with this is what happens when we assign the f value a second function. Okay? So here we call g, and so g will then assign to our empty variable this f function. Okay? And then if we call h afterwards, or actually let's do it after calling f for the first time. So as we then call h, then the f variable will be assigned again. So then a second function, which is this one here. And so what I want to see is what f does then. So let's see. And again, keeping in mind that f at this point is a different function than this one here, because it was reassigned by h. We just write that here. Okay, and now we get 1554, which is probably 777 times 2, and indeed it is. And so this proves that the f function that was reassigned here also closed over the variable environment of h. And so that's how it can access then the b variable here, which is set to 777. So let's actually inspect the variable environment like we did by the end of the last video. So of f. And then we will be able to see that in the closure, it does indeed have the value of b. And it now no longer has the value of a. So of the closure that it used to have before. So at this point here, the closure contained the value a. And we can, of course, also see that. So at this point in time, the closure is indeed a23, right? And so then as we reassign the function to a new value, then that old closure basically disappears. And yeah, now the closure is b. So this variable here of the birthplace where it was reassigned. And this is really fascinating in my opinion, that the closure can change like this as the variable is reassigned. So it really is true that a closure always makes sure that a function does not lose the connection to the variables that were present at its birthplace. So it's always going to remember them. And in our case here, the function was kind of born inside of g first, and then it was essentially reborn again in h. And so first, the closure contained the a variable of its first birthplace, and then as it was reborn, to follow our analogy, then it remembered this b variable of its birthplace. Okay? So this was example 1. Let's now create another example. Okay, so I hope the first one was clear here. So whenever something like this happens, where you reassign functions, even without returning them, keep in mind that also this will create a closure. But now moving on to our second example here, and that's going to be a timer. So a timer is another great example that we don't need to return a function to see a closure in action. So here I'm going back to the example of the airline. So creating a function called board passengers. And then we get the number of passengers and a wait time. Then let's create a new variable in here, which I'm calling per group. And that's because boarding usually happens in groups, and we usually have 3 groups. So I'm going to divide all the passengers, so the number of passengers that is boarding, by 3. And by the end of this function, I want to log to the console, we'll start boarding in, then wait seconds. Okay, And now let's actually use a timer. And we haven't actually used a timer yet in this course, and we will learn more about them later. But this is such a good use case that I wanted to use a timer now. And it's actually very simple. So we just use the set timeout function. And the set timeout function needs two parameters. The first one is a function which will be executed. Okay, and this function will be executed after a certain time. For example, we can specify 1000 milliseconds because the second argument here is milliseconds. And so that will mean that whatever code is inside of this function will be executed after 1 second. So let me actually do that out here just so you see this as an example. So if I save this now, wait 1 second, and then here you see timer appearing. So I'm going to do that again. Okay, so you see that after this 1 second, this function was executed. Okay, and so this, as we already learned before, is essentially a callback function. And in this case, it is literally called later. So in this case, after 1 second. So let's create our callback function here. And first, I want to log to the console. We are now boarding all, and then the n passengers. And so this n here is this parameter of the function. So of this parent function, which essentially is the function or the scope in which this callback function here is being created. And so that will of course be important for our closure example. And then let's also use the per group variable now. There are 3 groups, each with passengers. Okay, that's our function, and now let's call it. Oh, and here we want to specify weight, and then times 1000, because we're going to pass in the weight in seconds. And this argument here needs to be in milliseconds, and so we just multiply by 1000. So, board passengers, let's say we have 180 passengers, and it takes let's say 3 seconds. So immediately when we call this function, this variable will be created, then set timeout will be called, and it will basically register this callback function here, and then that will be called after 3 seconds. But immediately also this console.log here will be called. All right. So this console.log here will not wait these 3 seconds for the set timeout callback to finish. Okay. So immediately this variable is created, the set timeout function is run, and console.log is run. And then after 3 seconds, this function here will be executed. And so let's see what happens to the n variable and to the per group variable that is in this function. So immediately we get this log. And then after 3 seconds, we are boarding all 180, and there are 3 groups with 60 passengers each. Okay, it worked. And again, keep in mind that this callback function here was executed completely independently from the board passengers function. All right, but still, the callback function was able to use all the variables that were in the variable environment in which it was created. So that's n and per group. And one more time, this is a clear sign of a closure being created, right? So the only way in which this callback function here can have access to the variables that are defined in the board passengers function that has long finished execution is if it created a closure. And so that's exactly what happened. And yeah, that's how we got access to per group and also this argument of the function. So this weight here, right? So as I mentioned in the last lecture, the closure, of course, also includes the arguments, and that's because they are really just local variables in the function. And to finish, let's now also prove that the closure does, in fact, have priority over the scope chain. So here in the global scope, I'm also going to create a variable called per group equals, and then just some value here. And so if the scope chain had priority over the closure, then this callback function here would indeed use this variable here, this global variable, because we can imagine this function here basically being executed in the global scope. Okay, so if it wasn't for the closure, it would use this. So let me actually demonstrate that to you. So if I remove this variable, then it will be able to use the per group. And that is here outside. So indeed, now we get 1000. But then, as we put it back here, then the callback function will close over this variable. So it will close over the entire variable environment, in fact. And so therefore, it will then use this here first. Right? And it did. So, in fact, the closure even has priority over the scope chain. Okay, and with this, we finished these 2 lectures about closures. And I hope that after this one, you are now a little bit better able to identify closures as they happen in your code, or even here in my code throughout the course, because we will see some closures happening some more times in the future. Now all there's left to do is the coding challenge in the next video, where you will be thinking about closures one more time. To make sure 100% that you understand closures now, let's work on this coding challenge number 2. And actually, this one is more of a thinking challenge than a coding challenge. So what I want you to do is to take this iffy here, and at the end of the function, simply attach an event listener that changes the color of the selected h1 element. So this header here to blue. All right. And that should happen each time that the body element is clicked. So whenever we click here. And what's important here is that you do not select the h1 element again. So just use this header that you have here. All right. So that's all the code you have to write, which is really simple. But the real challenge here is that I want you to explain to yourself or even to someone around you why this works. So as you click the body, the text will change to blue, and so it's going to work, but you have to understand and you have to explain why it worked. And so this is a good exercise, because being able to explain something to someone else means that you have understood it yourself. So I really hope that you do this one, even though it doesn't involve a lot of coding, but it's still really important to do this. So take all the time that you need and think about when exactly the callback function is executed, and of course what that means for the variables that are involved in this example. So again, take the time that you need, and I see you here in a minute with my own explanation, basically. So the code that you had to write was simply this. So selecting the body element and then add event listener on click, and then this callback function. And then I'm simply changing the style here to blue. And keep in mind that we did not select the h1 here again. I simply used the header variable that we had already selected before. So let's give it a save, and I will click now the body, and indeed it became blue, and that worked just fine. So why did this work? Or in other words, how does this callback function here get access to the header variable? And one more time, the explanation is the closure. So I hoped that you really explained basically how the closure works to yourself or to someone else. And so in this particular example, the closure is necessary, or it's useful, because by the time this callback here is executed, this iffy, so this immediately invoked function expression is now long gone. So it has already been executed, and with it, this variable here is basically gone as well, right? So all of that is gone, but still this function here is attached to the body element. And so it's waiting for some event to happen there. And when the event happens, well, then this function here is of course executed. And again, even though the environment in which this function here was created is already gone, it is still able to access the variables that were created in that variable by the time the function was born, so to say. So this is the birthplace of our event handler function here, and therefore the function remembers all the variables present at the time of its birth. We can also say that the header is in the backpack of this function. So that explanation works as well. And you can go even further and deep into theory and basically try to explain how all of this works behind the scenes. But that I already explained to you in the more theory lecture, and so I'm not going to go into that again. All right. So hopefully you managed to explain this to yourself, maybe to your dog, whatever. But what's important is that you now understand how the closure works and how and when it appears. So this was yet another great example of a closure appearing. Anyway, with this, we finished this pretty important section on functions. And so in the next one, we will finally build another visual project with a graphical user interface, which is really exciting. So that section is all about arrays, and we're going to build together an awesome application there. So I hope to see you there as soon as possible.